Hi, my name is Louis Kowalik, and I was in charge of the computer software subsystem. I did all of the coding, and with that, I ended up building the actual circuit to make sure that everything would work properly when implemented. It also really helped with troubleshooting the code and making sure that all the bugs were fixed and that everything was going to work properly, as there were a couple things that we really haven't used that much, such as this numpad. We never use this in lab, and so making sure that everything worked properly and everything was going to work okay was really important. Also making sure that the code was coded properly and that everything worked as, we would like. Um, so I'm from Group 5. In this demonstration, we're going to talk about the parts. I'm going to show how the user would use the system properly. I'm going to show how the user would use the safe improperly, and that's just to show that all the bugs have been fixed and that the system isn't going to break. And I'm also going to show what would happen if someone acted as a thief. So I'm going to act as a thief, and I'm going to show you what happens if somebody were to try to break into the system, either by taking the safe or by entering as many codes as they might like, which isn't possible, but we'll get into that later. So we have a keypad, we have the servo, and we have the Arduino. We have an LCD screen, a piezo buzzer, and then a bunch of wiring to connect everything. And then over here we have an accelerometer. At the moment, I do not have the accelerometer hooked in. There's a wire out of it. And that's important because right now the accelerometer is sitting just at an angle. We'll get into why that's important later, and I'll show you how it would actually be working when mounted onto the safe. Sadly, due to COVID, we weren't able to get together as a group, and so we weren't able to actually make the safe. But I thought I wanted to go a little bit further and make everything to not only make sure that my code works properly, but to prove to you guys that the code is working as it should, as it's probably hard to grade the coding and read through it. But anyhow, we'll get started here. So let's say a user just bought our safe. So they plug it in, and this is how it starts. It says enter code, and that is in the locked position. I'm going to unlock it just for a second, just to show you what would happen if the user got it and the system was in unlocked position. They plug it into the wall, and it's resetted, and it always starts in the locked position. And that's important because to change the code, you need to have it in the unlocked position. And most locks, when you buy them from the store, they give you the preset code that it comes with, and then you can recode it later. And that's kind of how this system works too. So the code that would come with this safe automatically is 1, 2, 3, 4. And again, right now, I am going to show you the user using it properly. So everything I'm doing is perfectly done, and then I'll show you improperly later. So 1, 2, 3, 4, I enter that, I press the enter button, and it's entered. And now the system is unlocked, and me as the user, I have a couple options. I can A, clear what I wrote. Now I could close the system by pressing the C button. So if I press close, it closes after a short period. That way the user can shut the system and press the button, and then it will close. It has a slight delay of 3 seconds. Anyhow, if I press 1, 2, 3, 4, and I unlock the system again, at this point, the user most likely is going to change the code to be a code of their liking. So I'm going to change the code to 2580. And I'm going to press done or enter. And now it's back to the home screen, and you can see that 1, 2, 3, 4 does not work. And we'll clear that. And the right code is 2580. And if I press enter, everything works as it should, and no alarms go off. Everything works perfectly. All the buttons work. 1, 2, 3, 4, A, 4, 5, 6. B doesn't do anything because B, when we're in the unlocked position, shows us the new code. And we'll just make that 2580. And then 7, 8, 9. C makes it in the closed position, so it doesn't show up. We have star, which clears out everything, and then we have 0, and then this enters, and then we have D. So now I'm going to show you, I'm going to first clear this, and I'm going to show you what happens if, so our code again is 2580 is shown here. I'm going to press the clear button, or the close button rather, and I'm going to clear the code. So now I'm going to be the user, but I'm going to make a couple mistakes. I'm going to try and use the safe as not directed through the directions. So let's say I try entering the code. Let's say I get it wrong. So I do 1, 2, 5, and I press enter. Well, now my tally's at 1. Now I'm still the user, so let's say I press 1, 2, 5, 3, and I want to enter that. Well, now my tally's at 2. Now after 3 wrong attempts, the buzzer's going to go off. Now if I, try entering, let's say 5, 5, 5, and I try entering that, now the buzzer goes off, and the buzzer will continue going, but because I'm the user, I can turn off the buzzer by entering in the correct code, which is 2580. And as you can see, the system is unlocked. Now, let's say I close the system, and I tried to change the code. I can't change the code as the user when it's in the locked position. And that's important because you don't want a thief or somebody to walk up to your safe and just be able to change the code all willy-nilly and not have to show that they know the pin to change the code. So again, it needs to be in the open position for you to be able to change the code. So now that it's in the unlocked position, I can change the code by pressing the B button. And let's say I wanted to change the code to just 2. You actually can't do that. You see, nothing happens. It doesn't leave this screen because it needs to be 4 digits. So we'll clear that, and we'll make it 1, 2, 3A. And if I make it 1, 2, 3A, you'll see that is allowed. Now my code is 1, 2, 3A, and again, if I enter that and I want to change the code, I want to show you that you can't make it more than 4 digits. So again, if I try 2 digits, it doesn't work. If I try 3 digits, it doesn't work. If I try 5 digits, it just resets. If I try no digits, so no digits, it doesn't do anything. You can't enter a code with nothing in there. It needs to be filled with at least 4 digits, and no more than 4. So we're going to again make it 1, 2, 3A, and that's our code. Okay, now the code is 1, 2, 3A. I am now a thief, so I am not the user anymore, and I've walked up to this safe and I want to break in. So if I try entering the code 01739, well, that code is now going to make the wrong attempts 1. And if I do 2580 and I try entering, now my wrong attempts is at 2. Now at the 3rd wrong attempt, the system sends the piezo buzzer like as earlier. And I'll demonstrate that once more. So 2, 5, and we'll just try that. And as you can see, the piezo buzzer buzzes as it should, and this will continue buzzing. And it will hopefully attract others to see. It'll hopefully scare away, the person trying to break into the safe. And hopefully, they won't just ignore the piezo buzzer and continue doing as they're doing. And hopefully it'll attract some attention. But let's turn that off. So I'm going to clear, and I'm going to enter in the correct code. Okay, so the correct code is entered as seen. And now I'm going to again be a thief. So this time, the thief knows about the 3 incorrect codes. And so the thief is like, oh, well, I'm just going to, steal the safe. Well, that doesn't work well either. So let's close the system, And let's clear the code. So this thief comes up to the safe, and now here I'm going to plug in the wire to finish the accelerometer. Now, this accelerometer would always have the wires in, but this is just for demonstration's sake that I had it unplugged, and that's just so that it wasn't buzzing. So you'll see the accelerometer is connected to the safe, and if the safe moves in the Y direction, either down or up, it will buzz. So if I was the thief and I tried picking up the safe, which has the accelerometer connected to it, the piezo buzzer will buzz. And so as you can see, here I am demonstrating walking away with the safe, and the whole time the piezo buzzer is going nuts, hopefully attracting attention, hopefully scaring away the intruder, and hopefully keeping the person's valuables safe. And again, when it's set down and it's completely still, it does not buzz any longer. Again, I'm going to disconnect that cable just so that way it can kind of go topsy-turvy and move all around. And that's everything demonstrated. So again, this is group 5. My name is Louis Kowalik. I did all the coding for this Arduino. I circuited this myself at my house with all the parts from the kit. And I have shown that how the user would use it properly, what would happen if the user made a few mistakes, and what would happen if you were acting as a thief, trying to, break into the device and or steal the device. The only thing that isn't shown here that is in our project is something very simple. And it's something that I didn't show because I didn't want to take the risk of going out to the store of getting a 9-volt battery, because the 9-volt battery in my case or my kit is not very strong. I think the voltage on it is pretty dead. But it does work on a 9-volt battery. I did get to test it earlier. It's just that the one in my kit has since died. And what you would do is you would just have a switch, an inline switch, that the user would press to make the battery go in as shown on the schematic in the presentation and both in the final project proposal. I can assure you that it works properly. I just don't have it here to show you in person, as I did not go out to get the part. But everything else works, and thank you so much for watching.